Hello everyone, my name is Damon Rocha. I'm a robotics and embedded systems engineer working on robotic systems that learn to adapt and survive. Today, I'm going to show you a simple rover I built that learns to drive on its own, avoid obstacles, and map out an area using Python and AI. The rover itself uses Q reinforcement learning to teach itself which actions are good, which actions are bad, should it keep going the way it's going. And over time, it'll slowly get smarter and smarter as it learns what works and what doesn't. What you're seeing here is the rover and its obstacle course. It needs to avoid the thermal areas, which are the black tape, and the obstacles, which are the boxes. In the beginning, it does a terrible job of this because it knows nothing. And over the span of time, it'll slowly get better and better using the Q learning algorithm and the IR sensor that tracks the temperature fluctuations, which is orange for the ground, which you can see in the little thing on the bottom right, green for the white papers, and red for the black tape, and those represent thermal hazards. The Raspberry onboard Raspberry Pi runs all this together through these Q reinforcement learning nodes, and over time updates this table that tells the rover, should I do this, should I do that, what happens in this state, what happens in this state, and has up to 64 different states it can be in at a time. And more or less what this does is it tracks the best action to do when it's in any of those states. And those are all dependent on what the lidar picks up around it for any obstacles, and then the temperatures it finds, and the past actions it's done before. This is innovative because instead of following a script, this type of robot can be sent somewhere, put somewhere, and just optimized to just learn on its own, and it'll just slowly get better and better as it's in that environment longer without human interaction. And as you can see here, it's slowly but surely getting better and better, and then gets to a point where it converges on this last white piece of paper, is happy with this cool zone, and finishes up. And what you see here on the right is my updated uh, thermal map that it's made throughout this whole process. And with that, the rover has, in essence, learned how to navigate the area. I could take that table, save it, and then run it through again. And the next time through, it could start in a better state, update itself even more, and get more and more optimized as it goes through the environment more. As I kind of hinted at earlier, this is aimed at simulating survival logic for future rovers and robots, whether they're exploring other planets or harsh farmland or anywhere else on the Earth. It shows how AI can make decisions based on real time feedback and not worry so much about hard coded rules. On top of that, instead of just taking this table, saving it, and putting on a rover, the rovers would, in essence, always be in training. So that way, even if it came upon new environments, it would be able to update itself and keep learning. While the UX right now is super minimal, you just launch the rover, the map builds, and then once you finish, it finds the best spot. In the future, I would hope to add more complex algorithms and make the table and the simulation or the visualization more in depth. And with that, that concludes my demo. I'm super excited on continuing this and building upon it. Had I started this project a little earlier, I think I would have made this my main project I was working on for my senior project and going forward. But I think I'm going to integrate some of the things that I learned in this project into my senior project and then come back to this in the future with more advanced learning algorithms. Thank you very much.